In problem 30, we're told our certain rectangle has perimeter 120 centimeters, and that its length is its width plus 2 more than the width. We're asked to find its area. So here I've drawn a diagram, a picture of the rectangle in question, with the length and the width labeled. The perimeter is the sum of all these, w plus L plus w plus L, or 2 times L plus W, so we know that 120 is equal to 2 times L plus W. This is the perimeter, remember. Dividing by 2 on both sides of that, the 2's cancel out on the right, and so we get 60 equals L plus W. Or if we subtract W from both sides, we get that 60 minus W is equal to L. But L is equal to the width plus 2. So instead of L here, I can put W plus 2. And now we can solve for W. If I add W to both sides and subtract 2 from both sides, I get that 58 is equal to 2W. And dividing by 2 on both sides, get that W equals 29. And that's centimeters. Well, we know that the width is 29 centimeters. And therefore we know that the length is 2 centimeters more than the width. So we know that the length is 29 plus 2, 31 centimeters. And so finally we can answer the question about the area. The product of those two values, 29 times 31, is 899. So the area is 899 square centimeters. Again, multiplying the length times the width, we then get the area for this rectangle. Okay, now in problem 31, we're to solve this linear inequality. So we want to get all the x terms together. So I'm going to add 2x to both sides and add 7. The result is we have 4x is less than 28 plus 7, 35. Then dividing both sides by 4, we get that x is less than 35 fourths. So in set builder notation, this is the set of all x such that x is less than 35 fourths. And to graph this solution, we need a number line first. And here's 35/4. And you put a circle around 35/4 here. X is smaller than means to the left, so it's everything over here that's shaded. Not including the 35/4. And since infinity is at the end of the line on the left, negative infinity, positive infinity on the right, in interval notation we could express this as the interval from negative infinity up to 35/4. So those are the three ways of expressing the solution set, or three of the ways, to this linear inequality. Finally, we come to problem 32. To begin with, we distribute the 2 through the parentheses. And we get 2t plus 4 and 4t minus 12 over there. So 2t plus 4 minus 3t is less than or equal to 4t minus 12 plus 5. And 2t minus 3t is negative t, so this is 4 minus t less than or equal to 4t minus 7. And now let's add t to both sides. That brings all the t's to the right, so we don't want the 7 there. So to add 7 to both sides to get rid of that negative 7. 7 plus 4 is 11. Then divide by 5 on both sides. And we get that 11/5 is less than or equal to t. So we could write this in set builder notation as the set of all t such that t is bigger than or equal to 11/5. And let's graph that one. Here's a number line, and here's, say, 11/5. We'll draw a circle around 11. We're including or equal to, so we want to make this circle filled in. And t is bigger than or equal to that, so that's everything to the right. And since you can think of infinity as being at the end of the line to the right, this is also, you can also write this as the closed interval from 11/5 to infinity. So these are three ways of expressing the solution set to this linear inequality.